going to explain to you on how you should have gone about solving the quiz question. There were two sets of questions. The first one on the types of walls for the house. One type is 10 centimeter thick wood and the other 25 centimeter thick brick. Considering everything else being the same, the only thing different is the type of material and the thickness. So you should have used Fourier's law of conduction. But of course, before that, you must have your list of assumptions: steady state, no heat generation, constant thermal properties, and one-dimensional in x, x being the horizontal direction. So utilize 1.22 equation in your textbook, Fourier's law. Here, I've skipped the perpendicular area, so the unit would have been watt per meter squared. Yes. So in this case, you can let the T2 minus T1 as a constant because it's not changing for both cases. So the only thing different is the K over L between the brick and the wood. So you would have gone to the appendix to search for the thermal conductivity, and don't just pick the first thing that you see. Plywood is not the type of wall. Yeah? Though you may be able to see a common brick here on the same page, which has 0.72 watt per meter per Kelvin, you should have gone to the next page, continuation of the first one, and you would have seen woods there. There are two types. I think the first one is the one generally used for walls: maple, oak, etc., the hardwood. So the thermal conductivity is 0.159, and you proceeded. Generally in winter, cold, inside temperature is higher than outside. And so you let T in be T1, T outside be T2, and you would have gotten the heat flux for the brick across the thickness of the brick wall, 2.88 A, A being T2 minus T1, and for the wood is 1.59 A. And from here, you should have seen that Q brick has a larger heat flux, so it's losing heat more to the outside. Okay. The next set of question is on the two types of meat. Okay, the 5 centimeter thick beef slab, and the other is a veal. Now that's where a mistake happened. So either one is okay, whether you use a 3 centimeter thick veal slab or 4 centimeter thick veal slab as described on the figure, it's fine. Should be 3 centimeter thick veal slab. As before, you have the assumptions: steady state, no heat generation, constant thermal properties, one-dimensional in X. You could add no fats, all meat. Yes, and here you use again 122 Fourier's law. It's conduction. This time is the heat coming from the surrounding to the center of the meat because it came out of the refrigerator. Yes, so again, same procedure as you should have done with the walls. Yeah, all you need is the thermal conductivity and the thickness. But in this case, the thickness is not the thickness of the meat. It's half thickness because the surrounding heat would have entered from both sides to reach the center. So this is half thickness. So you go to the properties of common foods, you would have found lean beef. Now ground beef is a process, yeah, it's not from the animal. I mean, it's from the animal but it's been grounded. So you would need the lean beef and the veal. There are very little difference, but still, that's the whole purpose I set the question. And heat from the surface to the inside, you would have found Q beef is 18.8 and veal is 31.3. The veal will reach the room temperature faster. So that's your quiz.